Welcome back to the greenhouse. We've got an abnormally warm day today. It is like 70 degrees the day before Halloween here, and usually we've got snow on the ground. So we're sitting over here sweating while we're working outside. We've had some rain showers come by and about 50-mile-an-hour gusts. It's been super windy. We've got the sun finally breaking through, which feels great. All the little solar systems love it. So today we're breaking down and talking about our compost heated air. So we're going to be talking and breaking down all of the pieces that we're using and why we're doing things the way we're doing this year as opposed to years before. Now, if that sounds interesting, please consider subscribing to the channel. There goes the sun again. We really appreciate every subscriber. We've gotten tons of you guys, and we're astounded that you guys find all of this interesting. We're trying to put the best videos out that we can, but we are a limited crew, and we've got daily lives. I have a day job, and our end goal is to have a little permaculture nursery on our homestead and be able to share that with the world, basically. Be able to sell that stuff online or locally in our community like we do with our farmers market. You guys supporting us is absolutely awesome, so a huge thank you to everybody who watches this video. Please subscribe to the channel. So all that aside, I've got two fans here. Let's check these out. Now this is just a little waterproof DC fan. This thing's lasted like 6 years in here, so I am pretty impressed with this little Chinese fan that I got two of them for maybe $12 to $14 with shipping and everything. So these things have held up great. One ran my geothermal and one's been running my compost heat for the last 5 to 6 years. So very, very interesting to see the longevity on those. So we have this 130 cubic foot per minute inline fan. I'm trying to focus on it here so you guys can see every little bit and bob on this thing. Nice impeller there. And this thing has a lot more blades, but this is 88 cubic feet per minute to 130. So we've got a lot more flow there, not double, but close. So I want to see if we can't push more heat through that tubing and get better results with our compost heating and just kind of refine the air heating system, because it's quite simple, and especially if we use the right kind of materials. I'm going to set these fans down. So the first thing I want to talk about is this drain tile. Now, this isn't your average drain tile. This stuff has a pretty decent crush force. This is the stuff that they would use out in the fields underneath 10 feet of dirt. So having this hard ABS plastic versus aluminum in a conductive heat transfer, this aluminum's gonna win hands down. So in that plastic, all of the atoms are very close together and they're wound and bound very tight. So they don't really share heat very much. They are a better insulator. Now something like your aluminum or your metals, they have loose electrons and they allow the transfer. So the free electrons interact better and promote that heat to transfer through. You'll notice that if you touch a metal object and a plastic object in the same room, same ambient temperature, that metal is going to feel cold because it's immediately drawing heat from your hand, and the plastic is a better insulator. It's going to take a longer time to heat up that plastic, and that is the process of conduction. So I want to talk about conduction, the process of touching to transfer heat. So to be able to transfer that heat much more efficiently through a piece of metal than through a piece of rubber is going to make a huge difference in a compost pile. Just a cool little fun fact, how heat transfers through those solid objects through the process of conduction, it's just a whole bunch of vibrating atoms, and there's cool atoms and hot atoms. So all those atoms are bumping into each other. The hot ones are bumping the cold ones, transferring kinetic energy, and that is how heat moves through solid objects like that. It's just conduction, or the transfer of kinetic energy through the state. So I really just wanted to break that down and explain the process of the heat transfer through it, because that hot compost will come in contact with our tubing, and then our tubing will heat up the air that is moving through it, and if we have enough of it, we will be able to achieve some decent heat transfer. So enough of this all technical, let's go outside and do some work. We had some good rain showers come through earlier. I had to grab a long sleeve. It was darn cold rain. So coming up here, we've got a whole bunch of hose clamps and got ourselves a nut driver. Oh yeah, I picked myself some radishes here. I'm gonna wash those up and eat those. Getting all of our hoops pulled out. Flip the camera around here. So looking down, we've got almost built Jean Pain compost pile before the compost goes in. So I just ran a whole bunch of water. I ran this for maybe half an hour and filled this whole thing up. There was a lot of dust inside this thing, and I didn't want it to keep blowing through the greenhouse. So I wanted to clean that up, get any dust and debris out of that. All of that debris comes from when we're setting it up. It is wickedly windy. The tree is loud. All of that debris comes from when we're setting it up and running it into the greenhouse, taking it apart and stuff. Wood chips and all types of dirt and stuff fall in there. So cleaning it out is not something you think about, but it is pretty darn important. I had to set you guys up on my compost tea bucket. I've got a couple compost tea buckets, 5-gallon buckets back here, that I'm using to inoculate nitrogen into the water and have a faster delivery of nitrogen, and dispersing it on this pile as it's being built. So I'm going to get this thing situated. I'm going to be cutting this drain tile in half. There's a few marks from where I hit it with a shovel and stuff. I've used this thing for like 5 years or something like that, or 5.5 years. So the fact that it's so sturdy and lasts so long is great. Just multi-purposing that again. And one thing I will state, as I cut that to attach this aluminum ducting, now, it's not the most solid. I said it was semi-rigid. Now, this is rigid aluminum ducting. This is our cold air intake inside that feeds right to our stove. So, ideally, I want to find some of this for next year's compost heater, because I found these pieces for like $4. I got 3 of them for 12 bucks, and in the store they are more than $12 a piece for this semi-rigid here. So, being able to purchase that for just pennies on the dollar for myself, that was my ultimate choice as opposed to buying this new. So I'm gonna keep my eye out for old ducting and piece something together over the winter and next summer. So I have a nice metal heat transfer system, and I may just buy some decent piping and call it an investment. I didn't want to do that this year. I wanted to do it as cheap as possible, like always. We're going to be cutting in the dead center of this, attaching the aluminum, and then running it in, setting it up in the greenhouse, and we should be ready to transfer some heat. So I just went ahead and I looped all that back, and over by the greenhouse where it's going to go in, I've got my 2 points of transfer where I'm going to have air flowing in with a fan and air flowing out into the greenhouse. So we still are using it to transfer heat, but if we can heat up the air and then run it through these pipes without using the pipe to transfer the heat as much, we can insulate the air and it'll be much more insulated coming in. And with our pipe insulation, ducting insulation we've got, that cost us about $25. That's a nice experiment. I want to see what kind of temps we get this year. So we've got to make sure we have at least 4 foot from this point, 3-4 foot, so we can run it up into the greenhouse and have it set up. Basically what I'm saying is that we want to make sure we have enough on the end of our lines to be able to get to where we need to be inside the greenhouse, giving ourselves a little extra space there. So we're going to go ahead and cut this and pipe some aluminum in there. So most of the work is done now. I'm friggin' sweating from trying to get those 2 pipes in there together. I want one taller than the other, so I pulled them both out, gave one a little bit more, and pushed them through at the same time. That made it super easy. Those rigid pipes didn't want to rub against each other. They were pretty tight. That little transfer hole back here is not huge, so we barely had enough room for everything. We've got all our lines kind of smashed down. And now all we've got to do is attach a fan to the intake over there, right here. And this will be blowing out hot compost air. Eventually, my shirt fell off the door here. This is what we're working with out here. So we've got this one piece of transfer pipe, and then we've got all of our insulating lines, all of our drain tile that we've used to heat up before. And we saw hot temperatures, but it took a lot of heat to transfer it through there. So we were wasting a lot of heat and not transferring it into the air system. So taking a look real quick, basically when we dump this compost pile, all of these rings are going to be 2 to 3 foot away around this thing, and that wind is getting crazy. So we're going to be cutting this off pretty soon here, but this is the gist of it. We do not want our rings touching each other. We don't want them too close. We want compost to heat up, and these will be staggered in layers. These pipes will not be anywhere near each other. I know they're in a ring on the ground, but they're going to be 3-dimensional, and all of our compost will fill in around our barrel, allowing good heat to reach all of these systems. So I'm sure there's going to be questions on this, and if there is, you know where to drop them. I'm sure my wife is looking for me by now, so I'm gonna run inside real quick. I heard my son come out and yell for me, so I'm gonna let you guys go until next time.